Hello, students. From Hill-Ryerson Advanced Function Grade 12. I'm going to illustrate the examples in Chapter 4 and Unit 1. This is Marquis Learning Center, the tutoring class. This is our content and the major course we are teaching. I'm going to use simplified way to explain examples to you to help your study. Please subscribe my video. Thank you. On page 205, the first example, degree to you. Example 1, an angle 30 degrees is going to be converted into radian. So we're going to apply this formula. So it's equal 30 times pi 180 degrees. So it's equal 30 pi over 180 degrees. So 13 and 118 cancel. It's equal 60. So it's pi over 60. So it's the angle 30 degrees to radians. So if you want to get the exact value for decimal, then you're going to equal pi is 3.14 divide 60, and you're going to get 0.52 radians. That's how you convert it. Then is 5.86 radians. So we're going to times the conversion formula. So 180 degrees over pi. So, and how are you going to get it? You use a calculator. So if you use 5.86 times 180 and then divide 3.14. So you're going to get 335.92 degrees. We're going to run it up for one decimal. Or just run it to be a whole number. 3 is the verbal problem solving. It asks for the arc length for a given angle. Now, Susie choose a camel to ride on a castle. The camel is located 9 m from the center of the castle. If the castle turns through an angle of 5 pi over 6, determine the length of the arc length traveled by the camel to the nearest tenth of the meter. So I'm going to illustrate the way to solve it on paper. Now we're going to write down the formula first. So formula is the center is equal arc length divide the radius. So we analyze all the elements. The radius is 9 m. The angle is 5 pi over 6. What is the arc length? Then we do substitution. So we're going to put 5 pi over 6 is equal A divide the 5 pi times 9 over 6. So you're going to apply the calculator to find the line. Point 2, page 214, example 1. So apply trigonometric ratio for special triangle. So Ravender is flying his kite at the end of a 50 m stream. The sun is directly overhead, and the stream makes an angle of pi/6 with the ground. The wind speed increased, and the kite flies higher until the stream makes an angle of pi/3 with the ground. So as you can see, the diagram here. So the first time fly the kite is pi/6. When the wind blow it up, so the angle become pi/3. Now what the question is asking? So A, determine an exactly expression for the horizontal distance that shows of the kite moving between two positions of the kite. Now the first position, second and first, we are going to find the difference here. Now I'm going to write the illustration on paper. I drew two triangles separately. The first one is pi/6. We're going to find the baseline. And the next one is pi/3, fly higher. We're going to find the baseline. The long baseline subtract the short baseline, and that's the answer for the question. Now the two triangle, we're going to use a cosine to do it, since cosine is looking for the base. Now that's for the x1 and that's for the x2. So we're going to find x1. I'm going to move the camera a little bit in this way. So x1 is equal cosine pi/6 times 50. Now the next one is x2. So it's equal cosine pi/3 times 50. Now I drew the special triangle here and write down the ratio. So it's pi/6. Cosine is going to be √3/2. So we're going to write √3/2 times 50. So and how about pi/3? It will be 1/2. Now from here, we are going to do simplify. So division, this is a 1, that's 25. And this is a 1, and that's 25. So therefore, x2 is equal 25m. So how about x1? x1 is 25 over √3. So now we're going to find the difference of the base. So we're going to use x1, subtract x2. So which is 25 √3 minus 25. So from here, you can directly use a calculator. So 25 times √3 minus 25. Or you can factor 25 times √3 minus 1. So both are okay. So you're going to put 25 √3 minus 1. And we are using calculator. So use √3 minus 1 and then times 25. The answer is 18.3 m. And that's the difference. So we solve it. Now, the next example. Now, example 2, trigonometry ratio for a multiple of special angles. So use the unit circle to determine exact value of 6 trigonometry ratios. For the angle is 3 pi/4. I'm going to write on paper. Now, example 2, the angle is 3 pi over 4. So we draw it in a quadrant. So this is the principal angle, 3 pi over 4. The relative angle attached to the x-axis is pi over 4. So if it's the pi over 4, we write the special triangle. The ratio is 1, 1, and root 2. So we're going to write the 6 trigonometry ratios. First, we're going to write sine 3 pi over 4 is going to be opposite to hypotenuse is 1 over root 2. Now, the one for cosine, so we write here. So cosine 3 pi over 2 is same thing, 1 over root 2. So how about tangent? So tangent is going to be we're going to write here. So tangent is 1 over 1, but tangent in the second quadrant is negative. So therefore, we're going to write -1. So how about cosine in the second quadrant is also negative. So we put negative. So how about sine? So according to Castor rule, sine is positive here. So we're going to got one angle positive. That's Castor rule. Cosine positive, all positive, sine positive, and tangent positive. Now we're going to write the reciprocal angles. The reciprocal is quite simple. Like cosecant is the reciprocal of sine. You just flip over the ratio equal root 2. Now, how about cosine? The reciprocal is secant. So you're going to reciprocal. So it's going to be negative root 2. So how about cotangent? So it's 1. You can flip it upside down or down upside. They're all the same. So the reciprocal still, it's a -1. So that's how we write the 6 trigonometry ratios. You can remember it easily. So the examples is from this book, Ryerson Advanced Function, grade 12. And we finished the 2 units examples. And next class, I'm going to explain unit 4.3 and 4.4. So, and this is Smart Kids Learning Center class. And please subscribe my video. I'm going to continue explain examples and the test as well to help your study. See you in the next video. Thank you. Bye-bye.